Now let's look at a first order linear recurrence relation. How does it look like, right? So it's basically the relationship of the terms and the previous term. So you can write in this format: Tn plus 1 equals to b times Tn plus c, okay? With your initial value, T1 equals to a. Or you have another alternative where you start with Tn, and what's the previous term of Tn? That means it's Tn minus 1, right? Again, with the same format, b times the previous terms plus c, constant, right? So, and then your initial value, if you start with n, your initial value will be T0. Okay, so either of the form written here is acceptable for first order, and the n value here is more than or equals to 1. Now let's look at the recurrence relation or the difference equation for arithmetic progression. So for arithmetic progression, I write in the same format here. You have Tn plus 1 equals to Tn plus d, d being the common difference, and your T1 is, this is your initial term. So when is your first order having AP? So let's look at this. When your B value is actually equals to 1 and your D value equals to C. So B value equals to 1 and your D value equals to C here. D being your common difference. Now let's look at the geometric progression. So we are going to look at the difference equation or the recurrence relation for this. So again, I'm going to use the first equation here. So Tn plus 1 equals to R times Tn, okay? And then your T1 being A. So when is the first order actually becoming a geometric progression? That means your B value is actually equals to R. And what happened to your C? Is there any C value here? Nothing. So that means your C value equals to 0. So as explained above here, you have a conclusion. When is the first order actually becoming an AP? That means when your B is actually equals to 1, right? It's becoming an AP when B equals to 1 and D equals to C. And when is it becoming a GP? That means when your B equals to R and your C equals to 0. Okay, now what is a first order? Basically, first order involves a current term relationship with the previous term. So you have two terms involved. Now, what does it mean by a second order linear recurrence relation? That means you have three terms. So first order, you're having two terms involved. Second order, you have three terms, which is something like this, where you have Tn plus 2 and your previous two terms. Altogether here, you have three terms. Okay, but this is not in our syllabus. So we just introduce you about what is a second order, and that's it. Your exam focus will be on first order recurrence relation. Now let's look at the first order recurrence relation. When your B value is 1 and your C value is D, so you end up with this form, which is actually your arithmetic progression. So arithmetic progression, what is the features of it? When you have a graph, it will always have a straight line with the gradient D, which is your common difference, right? So your common difference, there are two of the possibility here. When the common difference is more than 0, that means your graph will always have a positive gradient. That means the term value will increase as the n value increases. Now, how does the graph of the AP looks like with d value more than 0? Okay, you have something like this. with this being the gradient. So how do I get the gradient? I'm sure you have learned this before. The difference in the y versus the difference in the x. So the gradient being, okay, now let's look at when d value is less than 0. When d value is actually less than 0, the terms of the sequence will have a straight line with negative gradient. That means the term value will actually decrease as n value decreases. And the straight line, the diagram will look something like this. Have a negative gradient, right? And then with the gradient being t, the same like the one before. And again, it's the same as the one, the gradient being the difference of y versus the difference of x. Now let's look at how to solve example 8. We are giving a diagram and it seems like you're having a linear form here. So you know you are going for arithmetic progression. When it's going downward, that means it's arithmetic decay. So the question wants you to find recurrence relation to generate the terms of the sequence here. So let's look at the first point. I just write the coordinates here. So this is x is 1, the y value is 22. Let's look at the second value. It's 2. Your y-axis is actually 18. Okay, and then let's look at the third one. The third one is 3 versus 14. Okay, so how does the format of arithmetic progression look like in terms of recurrence relation? So Tn plus 1 equals to Tn plus D. D being the common difference, T1 equals to A. Now what is the common difference? So you can use the standard format that you have learned. You use T2 minus T1. Okay, then you end up with T2. This is T2 value, 18 minus 22. Then you end up with negative 4. Another approach where you can do is basically you look at in terms of what I've told you before, difference in y minus the difference over the difference in x, right? So what is the difference in y? So I'm going to use 18 minus 22 versus the x is 2 minus 1, right? So I believe this approach you all have learned it before. So this is the difference in y over the difference in x, right? To get the gradient. So in this case, I get negative 4 over 1. Again, same thing. So it's up to you, whichever approach you like to find the common difference, right? Personally, I prefer this. So it's up to you, right? So what is the first value? T1. So T1 is 22. So you know that T1 is 22. So let's compile your answer. You are supposed to give the recurrence relation. Tn plus 1 equals to Tn minus 4. And do remember to include the first term being 22. So the answer needed for recurrence relation is always in 2. So it's being this, the 1 mark and the second mark. Remember, your answer must be complete.